Hi there, welcome to edupediaworld.com. You're watching the videos on areas of parallelogram and triangles. So in this video we'll discuss parallelograms on the same base and parallel lines, how we can identify the parallelograms which are on the same base and between the same parallel lines. Then we'll discuss the theorem. We'll also discuss the proof of the theorem, how we can prove them that if the parallelogram lie between the same base and the same parallel lines, how the areas are equal. Then we'll discuss examples, some of the examples related to this theorem. So let's get started with the first topic, which is parallelogram. Now, parallelogram on the same base and between same parallel lines, how we can identify them. Now, if you can see properly, if this is a parallelogram, PD, C, Q, P, so this is one parallelogram, PD, CQ, and if you can see properly, another parallelogram, which is A, B, C, D, A. So A, B, C, D. So this is another parallelogram. So you can see that both these parallelograms lie between the same base DC and between the same parallel lines BP and DC. So this is how we identify the parallelograms that lie between same base and between same parallel line. So let's discuss the theorem. Let's let it do this now. The theorem says that parallelograms on the same base and between the same parallel lines are equal in area. So we need to prove that. First of all, we need to prove that area of A, B, C, D is equals to area of E, F, C, D. Right? Now, so let's see how we can prove this. So first of all, we need to write given. So it's given that both A, B, C, D and E, F, C, D are parallelograms and they lie on same base. Right? Now, so let's see how we can prove this. Now, if you consider triangle ADE and ADE and triangle BFC, in this triangle we can say that this angle equals to this angle. Why? Because AD is parallel to BC and AF is transversal. So we can say that angle DAE is equals to angle CBF. Why? Because AD is parallel to BC and they make a pair of corresponding angles, and we all know the corresponding angles are equal and AF is transversal. Now, similarly, we can say that this angle equals to this angle. Let's say we can write angle DEA equals to angle CFB equal. Why? Because ED is parallel to FC and they make a pair of corresponding angles and AF is transversal. Right? Now, so then we can say that AD equals to FC. Why? Because opposite sides are equal in parallelogram. So we can say that triangle ADE is congruent to triangle BFC by AAS. So angle side. So we can say that now that area of ADE is equals to area of BCF. Why? Because both the triangles are congruent. So we can say that if the two triangles are congruent, the areas are equal? Now we need to prove that both the areas of the parallelograms are equal. So we can write area of ABCD as area of ADE plus area of EBCD. You can see properly. Say if this is a parallelogram ABCD, so we can write this area as this area plus this area, right? Now since area of ADE is equals to area of BCF, we have proved, so we can write instead of ADE BCF, so we can write area of BCF plus area of EBCD, right? Now if you see properly, EFCD will be the area of EBCD plus area of BCF, so means this area plus this area, so we can write this as area of EFCD. So we can say that area of ABCD is equals to area of EFCD. So this is how we can prove this theorem, that if the parallelograms lie on the same base and between the same parallel line, they are equal in area. Now, so let's discuss the example related to this. Now, the first example is ABCD is a parallelogram. So ABCD, this is parallelogram, and EFCD is a rectangle. So this is a rectangle, right? Then also AL is perpendicular to DC, so we need to prove that area of ABCD is equals to area of EFCD. Now if you can see properly that area of ABCD and area of EFCD, they are between the same parallel lines EB and CD, and they are between the same base CD, so we can say that by theorem area of ABCD is equals to area of EFCD, right? Why? Because they are between the same base CD and parallel lines, we can say BE and CD, so both the areas are equal. Now so let's see how we can prove the second part. So area of ABCD, as we all know that, as we have learned in the previous classes also, area of parallelogram is always equals to base into corresponding height, right? So we can say that area of ABCD, if we take base as CD, then corresponding height will be FC, so this FC will be the corresponding height. Now since AFCL is a rectangle, so why it's a rectangle? Because you can see properly AFCL is a rectangle, so why it's a rectangle? Because AL is perpendicular to CD, so it makes a rectangle. Now since then we can say that AL will be equals to FC, so we can say that AL will be equals to FC. Why? Because opposite sides in rectangle are equal, right? So we can say that area of ABCD equals to CD into AL. So this is how we can prove these type of questions. So let's discuss the next example and also the last example of this video. Now if a triangle and a parallelogram are on the same base and between the same parallel lines, then prove that area of triangle is half the area of the parallelogram. So we need to prove that area of triangle is equals to half the area of parallelogram. So means we need to prove over here area of A, B, P is half the area of AB, CD. So let's see how we can prove this. Now here we are given that ABCD is a parallelogram, right? And ABP, triangle ABP, they lie on same base AB and between same parallel lines we can say CP and AB. Now for a construction, what we need to know, we need to draw a parallel line BQ which is exactly parallel to AP. So we can write construction over here, draw a parallel line BQ to AP, right? Now so let's see how we can prove this. Now if you consider, see that area of ABCD is equals to area of ABQP, right? So why ABQP? Because they are on same base AB and between same parallel lines CP and AB, right? Now if you can see properly that if this is a parallelogram AB PQ and BP is a diagonal, so as we all know that the diagonals divides a parallelogram into two congruent triangles, so we can say that area of ABP will be half the area of ABQP. Why? Because diagonal BP divides a parallelogram into two congruent triangles, right? So now since area of ABPQ equals to area of ABCD, so we can say that area of ABP will be half of area of ABCD. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.